When UCLA engineering professor Aydogan Ozcan was a kid, he loved to see how things worked.
Whether it was a camera or a radio or even a pen, I would definitely open it up and look what's inside.
And it was breaking into a digital camera a few years back that led Ozcan to a revolutionary invention that could one day reduce the need for expensive microscopes and change the way diseases are diagnosed.
So I had that idea that I want to use just the sensor array itself. Of course, I was very excited, but then I had to test it.
First, Ozcan removed the protective cover of a regular digital camera chip. Then he placed cell samples directly on the camera's sensor, which is made up of an array of millions of pixels, each of which is sensitive to light, just like our own eyes. He immediately saw the cell's shadows.
So that was a remarkable moment that I said, yes, it's going to work.
The digital camera's sensor captured a holographic image of the cells that contained vastly more information about the shape and the health of the cell than a regular microscope could. Ozcan had invented a new way of looking at microscopic particles without using lenses.
So this is our lab space where we test our ideas. We can detect holograms of each cell or bacteria digitally. So for each cell type that we want to analyze, we have library images of the same hologram, of the same cell type. What we do is we load the library images of that hologram, and then the algorithm does a pattern matching. So we can identify all the red blood cells based on a match to what we have in our library images. So if there was a disease like malaria, for instance, you would see the hologram of the red blood cells show deficiencies. So that disease would actually show a contrast difference.
Ozcan's invention is poised to radically change the way diseases are detected and monitored.
There are parts of the world, unfortunately, that don't have these resources. There's no laboratory, there's no infrastructure to send it and get the results back. So there's nothing out there to provide you some basic tests regarding the patient's health.
In developing countries, microscopes and the advanced labs needed to analyze what they see are often just too expensive. So Ozcan came up with the idea of using the digital camera sensors that are found inside something that millions of people carry with them every day.
So this is the cell phone, okay? And I'll open its case here. Cell phones are everywhere. Even in Africa, almost 20% of the population uses cell phones actively. And we can actually capture that image with just a cell phone as you use it and wirelessly transmit that to a PC station. The results will then be sent back as a text message.
A text message that could save lives.
It's great to invent a wonderful device that's very sophisticated that can do wonderful things for the developing world.
And because the digital technology is so efficient, disease researchers all over the world could benefit as well.
If you want to understand diseases like cancer, you really need to go to the genome because cancer is a genetic disease. And you need to collect a lot of data.
With billions of cells to analyze, the faster, the better.
What most excites me about this technology is the speed that it enables. We can look at literally millions of cells per second, all with the holographic resolution that we want.
And it might just give hope to people living in parts of the world where diagnosing what's wrong quickly and inexpensively could mean the difference between life and death.